Okay, hey, good morning guys, and welcome back to the lecture. So we are already in week 4 now, and I think your friend has already finished his break, so we can get started. And today we'll be finishing up what we have left off in lecture 3 on network addressing. We just have one more PC to configure. After that, we will look into how we can configure a Cisco router, which is the whole lecture 4. So before we talk about the lectures, I just want to start with a news that can wake you up. So if you check on Weber, you can actually see there is a countdown timer there, which is already started and running, and that is not for your holiday or Christmas or Chinese New Year. That is for your quiz 1. And we'll be having a quiz 1 this Friday morning. So this quiz is actually a 1-hour test, and it is MCQ, meaning that there are only 20 questions, 20 multiple choice questions, and we will be doing this on Weber. I'm not sure whether you have done this before that, but if you have experience, then that's cool. If you do not, if not familiar, then I'll just explain a little bit about how you'll be doing your quiz. So on the day of the quiz, which is on Friday, this Friday, you will get a link on Weber that will bring you to the quiz. Okay, the questions will be on Weber, and you have 1 hour to finish the quiz, meaning that when you click on the link, it will ask you whether you want to start the quiz. When you click on the start button, then the countdown timer will start to run. So you have 1 hour after you click on the start button, but you can do the quiz anytime from 9 to 12. So the submissions, the last submissions will be 12, and then you can do it anytime in between, whenever you think you're ready or you're free or you do not have a class. So for those who are having class, then you might have to you will only be able to do the quiz during the lectures hour. So which means that on this Friday we will not be having any lecture class because we'll be doing your quiz during the lectures hour. But again, you can always do it as you feel that you are ready for it, okay? So before I go further about the quiz, can I know any of you have any questions? If you do not have, then because I do not know whether you can hear me or not yet, so can somebody reply on the chat that you can hear me right now, and then I'll continue with the stream. Okay, cool. Thank you very much. So if you haven't noticed already, actually on YouTube there's a bit of delay, like 5 seconds, so which is why every time I ask you a question I might have to wait for a while. Anyway, that's fine. Going back to the quiz, now for the scope for this quiz, it is from lecture 1 to lecture 3. Okay, so today we'll be talking about lecture 4 that is not in this quiz. So the quiz will only cover for the first week when we talk about all the network command and services, that's one, and then of course on network addressing as well. So lecture 1, 2, 3, which is everything from big 1 to big 3. Okay. Now remember if you have, okay, now let's say if you want to know what do you need to study for, first thing of course is you should already watch all the video by now. So if you have already attended most of the online stream, this shouldn't be a problem because by now you should have enough for the quiz. Now another thing is, in some of the lectures video you see there are QR codes that will bring you to the Medium post, and those Medium posts are like what we said earlier, a more detailed explanation on the concept that we have learned, and you should also read about that. Okay, now if you want to know whether the quiz will be easy or will be hard, it is very subjective, because I can say that if you have been following all this while, it will be easy, so that's fine but because you see, easy for me doesn't mean it is easy for you. So what I can say is that if you have watched the video, if you have read all the Medium blog posts that is related, then you will get, you can score in this quiz. Okay, so I think that's pretty much it. And what you should know, one more thing is that when you're doing the quiz on Weber, please make sure you click on the submit button. Okay, when you finish the quiz, it doesn't mean that it is automatically submitted. So there's one submit button that you have to make sure you click, and you will get a confirmation message saying that you have already submitted your quiz. And that is how you know that you have done your quiz properly. Okay, so again, because this is a quiz, all the standard exam rules will apply. Okay, that means that you shouldn't be discussing with any of your friends if you already met some of your new friends, and your questions will be different from each other. Okay, that means that student A will get a different set of questions compared to student B, but all of these questions, the difficulty are the same, and they are all coming from the same scope. Okay, now I'll open the floor for 2 minutes. If you have anything else that you would like to know more about the quiz, you can put it out on the chat, and then I'll explain further to you. Okay, so we have one question from Angie. I'll project this up. Okay, now this question, Angie is asking, should you be reading only from lecture slides, or you should read about the practicals? Now, you need to know both. Okay, you see, in data comm, we don't have a clear line between lectures and practical, because what you learn in the lecture, the theoretical part, you will apply them in the labs. So with lab and the lectures, you get the whole picture on the concept and also how to implement and use them. So to answer this question, yes, you have to study for both the lecture notes and the related lab. So in this case, for the related lab, it is only for lab 1 and lab 2. I don't think you need lab 2, right? Okay, there's no need lab 2, so only lab 1. Okay, so for those who are not clear, the scope will cover for lab 1. Okay, next question here. Okay, for this quiz 1, it is all purely MCQ, 20 questions MCQ. Okay, and even for midterm test, it is also the same. So for your quiz and midterm, both are all MCQ. You don't have to write anything except for your name. So yeah, will you know your result right after you click submit? Yes, immediately you will get your score for your quiz once you click on the submit button. Okay, so which means that you have to make sure you did do well lah, because it is on weekend, and what you get will, it means that you will affect the mode for your entire weekend. So please make sure you prepare well for the quiz. Now, question. Okay, now will the quiz cover for the software you learn, like for example ZenMap and stuff like that, or even network commands like ping? So yes, in fact, a lot of them will be coming from the software, because one of the lectures is covering on all the network service and command, which is part of the scope, and your lab one is also about this software. Now, if you are asking, do you need this software to do the quiz? No, you do not have to run the software, but some of the questions will be related to this software that you have learned earlier. Okay, so for those who didn't get this earlier, yes, this Friday there is no lecture class, there is no stream. In fact, it is already posted on Weber, because I do not know how you want to take your quiz and attend the lecture at the same time lah. Anyway, which means that you are free to do this quiz 1 hour anytime from 9 to 12. Okay, so I guess that's it for the quiz. This is the first test, and of course wish you good luck lah. Don't worry too much about that, because if you are here today, that means you are already doing half of the work. You already won half of the battle. Okay, so we'll get into lecture 3 now to finish up the last PC. Bob has been waiting for us for quite some time. So let's help Bob to finish this lah. Oh, we have one more questions. Okay, now this is a very good questions. Thank you, Angie, for the questions. Now, again, like I say, the period of exam is from 9 to 12, but you can take any 1 hour. But after 12, the submission will be closed, meaning that if you start 11:59, you only have 1 minute to do the quiz. So unless you are the Flash, please don't try to do this. Okay, so let's get back into your lecture 3. So guys, all of you please bring up the packet tracer Bob the Builder. And last week we have done configuring IP address for PC1, PC2, 3, and 4. So we only have PC5 left, and we are going to do the same thing. Now, if you didn't catch this in the last lecture, we have already changed the subnet mask of LAN number 3, the one in yellow color, to /25. Okay, so what we really need to do today is to assign the first IP address that we can use in LAN 3 to PC5. Okay, and for that, of course, again, we have to do the calculations. I will show you how to do the calculations manually, and then I will show you how you do it using an IP calculator. Okay. So over here, as you can see, the network address for LAN 3 is 192.168.3.0. Okay, so this is the one. Now we will calculate the address range using this address first. Hold on a second. Okay, so we have 192.168.3.0. So this is given to us the network address of LAN 3. So for us to calculate the range, if you remember, we need a few information here. First, we need to know what is the network address, what is the first usable address, what is the last usable address, and then what is the broadcast address. Okay, now actually the address that you are seeing on the screen right now is already the network address with the mask /25. So to recap, /25 means that we have 25 network bits all set to 1. Okay, and the remaining one all set to 0. That is for the network address. So I will write the network mask /25 in red color in binary so that you know what is going on here. So as you can see on the screen, the first 25 bits here is 1, and then the last remaining 7 bits here is 0. So this is a /25 mask, meaning that we have 25 network bits all set to 1. Okay. Now, for us to calculate what is the broadcast address, you have to remember the rules. So the rule says that network address, we set all the host bits to 0. For the broadcast address, we set all the host bits to 1. Okay. So in that case, for the network address is 192. Why 192 is because you see all 1. In decimal, it means 255. So like we said earlier, the shortcut, if we see all 1, we can just rewrite the same value because even after you do the AND operation, you still get the same value, right? So 192.168.3. Okay, now over here, this is all 0. So you see in this case, 1 0 is 0, okay, and then the rest is all 0. So this is in decimal notation. If I convert this back, I will get 0 as the, this is binary, so I'll get back decimal. Now I will highlight this in orange color. The network address is highlighted in orange color, 192.168.3.0. Guys, if you haven't caught what I said earlier, we have already changed this to /25. The one you got in the board builder file is something is wrong. So I want you to change /25 from /24. Okay, change that value. I will continue calculation first, and then I'll get back to your questions. Okay. So for the broadcast address here, the first octet is 192. The second octet is 168. The third octet is 3, so all the same value. Now the last octet is where you have to be careful, because remember here, I will write the last octet in binary. The previous 3 octets, I put them in decimal because we want to save time. Okay, so over here, last octet in binary, so you have a 0 here. And then remember the rule says set all the host bit to 1. So this is the host bit here, 7 host bits. So 1, 1, 1, 1, 1, 1, 1. Now if I translate this binary number back to decimal, you can press calculator for that. So I will press the calculator for you. So you have 0, 1, 1, 1, 1, 1, 1, 1, 7, 1. Press convert, you will get 127. That means that the broadcast address for this network here is 192.168.3.127. Okay. Now, having these two addresses, we can easily calculate what is the first usable and what is the last usable address. So for the first usable, we take the network address plus 1. And with that, we'll get 192.168.3.1. Okay, now the last usable IP, you take the broadcast address minus 1. So for the last usable, you get 192.168.3.126. And that is how we get all the 4 address that we need to configure LAN 3 later. Okay, now before I go further, you can take a look at how I get all this value first, and I will be answering the questions on the chat at the same time. So I won't be projecting this one because other students might want to see this. I will just be replying from the chat directly. Okay, since Peter and Angela is asking the 0 no need to change to 1 or how to get the 127, I will briefly explain the last octet again. So for those who already know about this, you can just skip this one because I think some of the students might still be confused. So 192.168.3.0. Okay, I think that is a great question here. Since you have another student asking for /23, I'll explain with /25 first because you need to configure this on the network later. Now, for those who already know, just take this as a revision lah. So the reason we copy back the first 3 octets is because we have a /25 So if you want to visualize this one, it means 255, 255, 255. Okay. Now on the last octet, we have to convert to binary first. So if you convert 255, the /25 mask in binary, you have 1 0 0 0 0 0 0 0. Okay. So remember, this one is in binary, and the network rule says that for the network address, the last 7 bit here, all the host bit is set to 0, and then for the broadcast address, all set to 1. So now why over here it is 0? Okay, I will write this for you. I will just convert this one so in case you cannot get it. I will do it the slow way, guys, so please be patient here because not everybody can see the shortcut, so I will have to do this manually. So I'll convert 192 from decimal to binary first. So after the conversion, I get 11000000. Then I convert 168 from decimal to binary first. So I get 1010 1000. Okay, and then I convert 3 from decimal to binary. I get 0, 0, 0, 0, 0, 0, 1, 1. Now after that I convert 0. Okay, I convert all these things. I convert 0 to 0 in binary is like this. So what you are seeing here, this line here, I will highlight them in orange color. This one is the binary representation of the network address that you see here. Now, which means that if I want to write the mask now, the next thing is we write the mask in red color. We have 1, 1, 1, 1, 1, 1, 1, 1. This is all 25 1 here. Okay, so you have until here. And then you have 1 here. Okay, 25 mask. So you are cutting the network at here. And then the rest is all 0, 0, 0, 0, 0, 0, 0. Okay, so you see the reason I get back the same value is because if we do the AND operation here, meaning that I do AND operation here, I will get back exactly the same value one. So let's do this. Since we are already here, let's just do this. So you have 1, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1000 here, 0, 0, 0, 0, 0, 0, 1, 1 here. Now in this case here, because this is a 0 and 1, so 1 and with a 0, you get a 0, and then remaining all 0. So we can easily convert this value back to 192.168.3.0, and that is the network address here. So this one here is the network address. Okay, now for the last address here, it means that set all the host bit to 1, the broadcast address. So 192.168.3. So you have to remember here, this one is 0, and then you have 1, 1, 1, 1, 1, 1, 1, because this one is still considered the network bit. So if you translate this one back, then you will get 127. How to get 127? You just press the calculator, you'll get 127. Okay, so I'll show you one more time, Peter. This is how you get it. You put 7 1 here, convert, then you get 127. So this one here, 127. Okay, and after that it's quite simple, it's straightforward. You just take +1 -1. So 3.1, the last usable is 3.126. Okay, so Angela, I hope I have already answered your questions. And Peter, now is it clear for you already? Okay guys, for those who need more example, I don't think we have the time but anyway, if you want more example, I can put some extra example on Rebel with the answers. You go and try them out, and then you compare your answer whether you get it right or wrong. Okay, so just now we have a request here. So would that be okay? Who I'm not sure Chiapo or Chiapo. I don't know which is your surname. Would it be okay if I just post more example on Bible and then you guys go and try them out on your own? Okay, now guys, let's go back to our packet tracer and then we help Bob to finish up the rest of the network. Okay. So looking at the instructions here, remember always open the instruction first, and then we want to see what IP we want to set for PC5. So PC5 is quite easy. Set the first usable IP. Okay, now first usable IP means what? Go back to the range that we get earlier. We have 192.168.3.1. That is the first usable IP. Now, this part here you have to be careful. Remember, we always say that in packet tracer, when you click on, now remember when you click on the subnet mask, automatically it will auto-complete for you. That is a /24 mask by default because they are using classful addressing. And when we say /95, it is a classless addressing, CIDR. So you have to manually change the subnet mask here. Okay, this one have to change. So change to what? Okay, if you do not know the number, you can easily calculate this. The last octet in binary is 10000000, correct? Because /95. So in the last octet we have 1. The very first bit in the last octet we set it to 1. So you press convert, you will get the decimal 128, which means that a /25 mask is actually also 255.255.255.128 in the decimal notation. So remember, you have to change this one, otherwise you will lose 1 point for the subnet mask. Okay, now the default gateway is the last address in this network. So the last address, what is the last address? Let's check. The last address here is 126. So this one here, last address. Okay, so we're going to assign last address to the router and go to PC5 first. Okay, 192.168.3.126 because that is the last usable IP in LAN 3 when we have a /25 mask. So this time it is not 254. You don't have to guess about this. You can just calculate them. You will get all the correct address range. Okay. So if you have done this, that's it. Close PC5 and we only have one more thing to go, which is to configure this IP on router 0. So remember, always check the proper interface by doing always show port labels. This is important. If you haven't already turned it on, please turn it on now to find out the correct interface. So in this case, we want to set on this router FA10, this one. This is the one that connect to the yellow color network. So I go into this router, I go to FA10. Now your interface will be different again. So please check your interface properly. And then we just need to put in the router IP here. 126. Okay, now again, remember this is a /25 mask, so 255.255.128. So please be careful about the autocomplete here. Have to change the mask manually. And always remember to turn it on. Otherwise, you are just typing. If you don't turn it on, nobody know what you are doing. Okay, so you have to turn on the interface manually. And yeah, that's it. So if you have set this IP 126 on the router on the correct interface, you have also set the correct IP for PC5, most likely Bob has already finished all his mission. So hopefully this is correct. We can just do a check here. Hopefully lah, I also hope. Yeah, we got it. You know, this is very challenging, you know, on the live stream. What if I don't get all correct? Okay, so for those who want, okay, hold on a minute here. So for those who have already done all the configurations, the last thing you need to do is you click on the check activity, you will get a congratulations message. Yeah, if you get 16 out of 16, for your case, it should be 18 out of 18. That means you have already helped Bob to configure all the network address. So Bob said thanks, and now Bob already win the Employee of the Month award. Okay, now I will be answering your questions about Bob the Builder. First, for those who have already done that and get all full marks, you can save this packet tracer file. Okay, you can save it. And then if you want to retry this file again, you go and download a new copy from Rebel for you to try again. Okay. Okay, so Awong asked how to get 0111111. Hey, Awong, just now I said already, you go and look back at the video how to get as the 0 is. Okay, so one of our friends asking where the /25 is coming from. So again, for the third time, we have already changed the /24 in len 3 to /25. So okay, that's it, cool. Now we'll get back to the lecture slide. There are a few more concepts that we will finish up, and then we'll take a short break, then we'll see how we can configure routers. So let's get back to your lecture slide first. Now you can close this packet tracer already. For this class, we will not be using this file. Later on, we will do another file which is on your own, which means that today you will not be getting any PKA file, but instead you will be the artist, you will be the architect, you will be building your whole network on your own. Okay. Okay guys, now let's get back to your slide. We only have 20 minutes to finish this slide because we have quite a number of things to cover in the next one. So by now you should already learn about network addressing. So if you want to know what should you know, by now you should know how to calculate network addresses in terms of what is the network address, first usable IP, last usable IP, and the broadcast address. So that is the minimum. Now in these slides, what you are seeing is that in certain cases here, we want to keep some IP address for special use. So for example, like we said, the first address is a network address. It is never used for any host, because that address, we need it to represent the entire network, which means that in the network you can have many hosts. So for anyone from the outside, from the internet, want to talk to any host in a LAN, they need to talk to this network address. So a network address is representing the whole network. It is not used for any of a single PC. Now the broadcast address is the same. That is the address that you use if you want to talk to everyone else on the network. Okay, so in a short while you will learn about unicast, multicast, and broadcast, and with that you will understand how a broadcast address is being used. Now, other than these two, for the rest of the addresses you can freely assign to any host, but we have a few recommendations. So what you see here on the slide, it is not rules. It doesn't mean that you have to follow. It is just that we recommend you to follow this guideline. If you don't follow, your network will still work. Okay. Now, there are two ways we do this. First is some network or some company, they want to use the first few address for server, which means that if you have a DNS server, DHCP server, you want to keep 1.1, 1.2, 1.3, the first few be assigned to the server, okay, and then the rest we assign to the host. Now starting from the last few address, let's say this is this is 192.168.1.254, the last usable address. We want to assign to router. Okay, now what if you have two router? Then you will use the second last usable for the second router, which is .253. If you have three router, you will use the third last usable, means .252 will be given to the third router. So there are two ways lah. Another company, they will use the first few address for all the routers, means all router will get 1, 2, 3, and all the last few address like .254, .253 will be given to server. But that's okay, depending on how you want to design, that's okay. But if possible, we want to follow this guideline. The first few or the last few we want to keep either for the server or the routers. Okay. Now after this, you go to the next slide, you will see IP rules. Okay, this is not exactly IP rules number 4. You don't have to worry about 1, 2, 3. Okay, please don't try to study in terms of what is rule 1, what is rule 2. There's no need for that. You just need to understand what we are doing here. That's more than enough. Okay. Now over here, this slide is saying that every network has a network address, which is what you have seen earlier in the intro video. And the next thing is you want to learn about what happened when you talk to a host in your own LAN, and then what happened when you talk to a host outside your network. Okay, now I hope you can see the slides here. You go to these slides where you have a green and orange color network. So we want to understand really how the packet move. This is very important. If PC1 talk to PC2 and PC3. So I will explain now. First thing, the point of view. You are PC1 now. Don't look at the wrong place. Okay, start from PC1. So let's say we are PC1 today. And then PC1 want to talk to PC2. Okay, this is the first case study. Now the question is, do you think the packet will go directly from PC1 to PC2, or it will go to the router? So there are two ways this can go. You might be guessing. The first way is PC1 he go, I use this color. I think I only have this color here. Hold on, let me use this. So do you think it will go here and then go here? So this is the first way, and then it go back to the switch and then it go to PC. First way. Or do you think that it will just go directly from PC1 to PC2? What do you think? Now, the simple answer, the correct answer is it will go directly from PC1 to PC2 without needing to go to a router. Okay? So what exactly happened is that when PC1 want to talk to PC2, he will check whether PC2 is inside the same network. Now, how do he check? He have to calculate the network address. So you see, right now PC1 IP is 192.168.1.1. PC2 is 1.2. I want you to remember these two IP. So technically, the algorithm would be like this. PC1 will do a calculation. So now we are inside PC1. PC1 know that his IP is 192.168.1.1/24. And then he want to go to PC2. The destination IP is 192.168.1.2/24. So what he do is he will check whether PC2 is in the same LAN by comparing their network address. So this means that I have to calculate network address for both of these two IP address. Now this is very fast because you already learned this. I will just write the network address. If you do the calculations, you will get 192.168.1.0/24. This is the network address for the first IP, PC1 IP. Then he will count for PC2, 192.168.1.0 as well. It is the same because we have the same subnet mask here, correct? So /24. This is the network address for the second IP. With these two informations, you just do a comparison. So is these two value the same? Yeah, they are the same. This means that PC1 and PC2 is in the same network. Yeah. So this makes the data transfer to be very easy. If it is in the same network, destination is in the same network, I just send my packet to the switch directly, which means that in the end, the packet will go here and then go here directly, just like that. Okay, so that is what happened when PC1 sent a packet to PC2. Okay, so if you have any questions about this, put it on the chat before we go to the second example. Okay, all fine, right? 5, 4, 3, 2, 1. Am I still alive? Can you still hear me? Guys, everything okay? Someone say okay, then I go to the next one. Okay, thanks. Then go to example number 2. Okay, now in this example here, we want to use PC1 and then we send a packet to PC3. So of course, you know it is on different network because you can see this thing we are seeing from above, but for a PC, it's not like that. The only way PC can know is by doing the AND operations and then you compare the two network address. So the same thing will happen here. PC1 sent to PC3, he will calculate the network address. So I will just write the IP address directly here since you're already familiar. After you do the calculations, you will get 192.168.1.0/24 for PC1, which is here. And then after you do the calculations here, you will get 192.168.2.0/24 for PC3, which is also already given here. So PC1 will now compare these two addresses. So I compare this address and this address. Is it the same? Definitely not the same. So PC1 know the destination is in some other LAN other than his own network. Now, in this case, for PC1 to send the packet, he will send this to its router, which means the router that is currently connecting LAN 1 to other LAN, to other network. Okay, so the packet flow will happen in this way. PC1 knows that I want to get to the internet. The packet will go to the switch and then go to the router. From the router, it will do routing, and all the routing will bring this packet to the destination. Of course, after that, it will still come back the other way around. Okay, so one way go, one way back. If this is a ping, then it's always two-way. Remember, ping is two-way. Now, you don't have to worry about what happened here. We will learn more about this when we talk about routing. So as of now, you only need to know if I send to someone on the internet, I will send the packet to the router. Okay, if you are cool with these two concepts, that's it for the addressing here. Now you go to the next slide. So the next slide says that we have special address. So everyone is special, okay? Even for IP address, we have some address which are special. So how can we say the address is special? It's because they are reserved for special purpose use. So remember just now, we say that the network address and the broadcast address, we cannot assign to any PC. Other than that, all can use. But there are also a few more address that we cannot assign to PC because there are different use for them. One of it is the loopback address. So on the slide, you see 127.0.0.1. That is actually a loopback address for yourself. Loopback address means what? Means yourself, like your IC. So I don't know about you, but some people don't call them weird, but some people like to call themselves by their name. So for example, say, I'm Awo. Awo is happy today. Today is Friday. Awo is going to IKEA sales later. So some people, they address them as first person, And if you want to address yourself in a network, you use this loopback address 127.0.0.1. And what is this for? Now, for example, if today you try to go to the internet but cannot, then you know somewhere something is wrong. So normally we will try to ping to see whether we can go to a destination, okay? But you see, when I ping and then cannot, the first thing I will blame is, internet down, server lag. So it is always someone else's problem. It is never our own problem. But you see, in some cases, it could be you. It could be that your network card, the NIC is broken. It could be something wrong with your own machine. So to make sure to isolate the problem, it is not you, it is the internet, it is Unify or someone else that's causing the connections problem. You should ping yourself first. So in fact, you can try this. You can open up your command prompt. So in the place of command prompt, you can actually ping 127.0.0.1. So you see, if you do this, you also get reply, and this means that my PC is okay. I can go to the network. If something is wrong, if I cannot go to the internet, it is not me, it is unified problem. Because you see, I ping myself, I get a reply. So that is how you use this address for. Okay. Now, if you're okay, then we'll go to the last slide for lecture 3, which is on some other special addresses. So just let me stop my ping first, because otherwise it will be pinging myself for so many times. Okay, now I'll get to the question first. So if PC1 send packet to PC2 by using same network, also same. Okay, yeah, correct. Fox is asking whether PC1 send to PC2 is the same if they're in the same network. Yes, these network rules are the same. Everybody follow the same rules. Okay, so what we have shown earlier is very simple, only 2 rules. If your neighbor or the destination is your neighbor, send to the switch. If the destination is somewhere outside, send to the router, just like that. So Peter is asking, how do you ping yourself on the phone? Now Peter, for that, there is no command prompt on your phone. You can download some apps. They call this network scan or network utility or network manager. There are many names for that, but there are apps that you can use to do a ping test or things like that on your phone. Okay. So Joey is asking, network address is the same as LAN. Technically no. LAN stands for local area network. So LAN is also a network, is also a subnet. But a network address is the address that is representing that network. So for example, if I live in Damansara, okay, so Damansara is the area, right? And for people to identify Damansara, you have area code for Damansara. That area code is like the network address for that town, that area. So network LAN is the network, and then the network address is the address that represents that LAN. Okay, cool. So you have one friend suggested, for those who want to try what we have learned, because we have been doing all these things on a PC. If you want to do it on the phone, you have to find some software or apps to do it lah. So your friend is saying terminal emulator work for Android. I hope it is free, and if it is free, then you guys can go and try it out lah. Okay, so if there's no more questions, we'll get to the last IP rules here, and then we'll go for a short break. Now, what you are seeing on the slides is 3 ways of addressing. So this is important. In datacom, there are only really 3 ways. I mean 4 ways, okay? When you want to talk to someone on the network, there are 4 ways. So the first way is the most prominent way. It means that most of the traffic that you have on the network is actually a unicast. Okay, now what is unicast? Unicast means that in a network, you have many people. So looking at the diagram here, we are the red color one. So I only want to talk to 1 people or 1 node at one time. Okay, so it means that if I want to send 2 packets to 2 different persons, I will do it 2 times. I have to send 2 packets separately 2 times. So what you see here, for example, is that here you see the red color host is sending a packet to the green color host. So 1 to 1, this is a unicast. Okay, now that means if how do we send a unicast? You build a packet, and then in the destination IP, you put any destination host IP that is not special address. So for example, just now we say other than the network address and broadcast address, all IP can assign to the host in the network. Now if you send a packet to any of the IP that we can assign to a host, it will be unicast because you are sending to 1 people. Okay, so for example, it's like if you want to find a boyfriend, you should find a boyfriend like that. When that guy say I love you, he only say to 1 person. So that's a good boyfriend, a sign of a good boyfriend. Okay, now whereas multicast is a sign of not so good boyfriend, meaning that when he say I love you, he say it to all the people. He has a group lah, of all the girlfriend, and then everybody will get I love you. So that is not a good sign, which means that multicast is you are sending the same packet to a few people in a group. So you might be thinking, what is a group? Now, a multicast group is a special address range, just like your Facebook group, your WeChat group. So you have all these group where if you join the group, every time you post a message in that group, you'll get everyone in the group will get the message. So that is kind of the multicast in datacom, in the computer network. Okay, so this is for convenient, like if you are in the chatting applications and then you want to talk, you want to send the same message to a few people, but not all the people, then you use a multicast. Okay, you see, for example, if like I want to tell FICT student about datacom quiz, I will post in post in the datacom Weber, because all of us are in the same Weber group. But I won't post to FICT website because not all FICT student is taking datacom this semester. So that is like a multicast. Okay. Now, how do you send to a multicast address? If you look at the slide here, there is this address range 224.0.00 to 239.255. That is the multicast range, which means that if you send any packet to this address range, everyone in the same group will get the packet. So how it really works is that first step, everyone have to join a group first. So for example here, this guy, and this guy, they join a group called 224.2.2.2. If this happen, it means that in this group you have 3 people. These people here, these people here, and these people here. So let's say I label them as 1, 2, 3. So 1, 2, 3. So this 1, 2, 3 is in the same group. Okay. The next time I send a packet, when I send a packet here, so let's say this guy sent a packet, he sent it to the destination IP, which is 224.2.2.2, this IP, then the host 1, 2, 3 will get the packet because they belongs to that group. That is how you use multicast. Now, the last type of address is called a broadcast. Broadcast means I want everyone on the network to know, okay? Which is very important because you see, multicast means I want selected people to know. And then if I want to send to everyone, I don't want everyone to join a group. By default, there's already a group for that, which is the broadcast. And the way you send it to broadcast is you send the packet to the broadcast address of the network. So in our example earlier, I will send to 192.168.1.255. If I send to this address, it means that everyone in LAN 1 will get the packet because they are belonging to the same net. So you can think of this like broadcast is, you know, the WhatsApp group, the anti-WhatsApp group, right? That's the group that is the speed of the message that they can share is faster than the speed of light, So that is like broadcast. If you anything that you tell to the auntie, when it go to the WhatsApp group, then the whole taman will know. So that is broadcast. Okay. And another thing you should know about broadcast is that it is used a lot in things like DHCP and some other protocol because there are certain packets that we need to announce to everyone on the network. Now, for example, we have learned about dynamic IP. Remember that we say every time a host joins a new network, the first thing he will do is he will ask for an IP address from the DHCP server. And the server can be what? Can be a real server or it can be the router. Remember, we say router is also a DHCP server, the guy who gives you IP. So you see, in the first place, when I join the network, I don't know anyone. So when I ask for IP, I don't know who should I be asking from, right? So in this case, when I want to get an IP, I will ask everyone on the network, hey, who is the DHCP server? If you are the DHCP server, please give me an IP. So you see, I have to ask everyone. So in those kind of case, we will use a broadcast message. Okay, that's what it is used for. But one more thing is, broadcast message only travel to the people in the same LAN. Okay, it doesn't go to anyone outside your LAN. So for example, if we go back to let's say I go back to this. I'll give you one example first. So let's say if you have a network like this, so you have over here I have two networks, okay? The left side in green color, the right side in orange color. So I have LAN 2 and LAN 1. Now, over here, if this guy here, the red color one, he sent a broadcast message, this message will be sent to this guy. Okay, I will add a few more hosts so that you get the what is broadcast about. This message will also be sent to this guy. It is also sent to the router. So everyone in the network will get that message, but this message will not go here. Okay, a broadcast message doesn't go across the LAN. We send to everyone in our same LAN only. That is broadcast message. Okay, so I hope you're clear with the three kind of addressing here. Actually, just now I said 4. The last one is called the Unicast. And Unicast, you only get them in IPv6. So we are not going to talk about Unicast today. And what is important for you to know is how is Unicast different from multicast and how is it different from the broadcast address. So that's it. If you have any questions about network addressing, please ask in the chat. For those who want to take a break or coffee or your breakfast is ready, please go ahead, enjoy your breakfast. We'll come back in 10 minutes. 9:15, we'll see each other again here, and then we'll go into lecture 4 on how to configure a network router. Okay, so guys, please go and take a break. I'll see you in a short while. Okay. Sorry. So I think I have already turned it on now. So for lecture 4, we'll be going into lecture 4 now, and then lecture 4 is a very short lecture, and we want to learn how to configure a Cisco router. And this router, it is different from the one that you have in your house lah. Because if you have ever configured your own router, then okay, if you have ever configured a router, you will see that you use a mouse, you go to a web browser, and then you type in your router IP. Then you will see the website or the web page where you can change your IP, you can set up your new Wi-Fi name. All those is different. Okay, now this router here will be using commands. We call this the Cisco CLI, command line interface, and then no marks. Okay, we say no to animal cruelty. And then also another important thing is that you will learn to configure a few different service on this router that you cannot do this on the normal router. Okay, so what you learn here is very similar to what you will do in the lab, which means that over here I'll be telling you about the concepts and the basics of how you use this command, so that when you go to the lab, you know what you are typing instead of you are just typing to finish the lab. Okay, so it is important that you know what you're doing in the lab, not just I want to finish the lab. Okay, so before we get into how to configure a Cisco router, I'll play you 2 short videos to explain what is a network router and then what do you have inside a network router. After that, we'll go to packet tracer and then we'll build a network based on the cheat sheet that you get, and then you will save the file as a cheat sheet. So if you look at Weber, you will get 2 files this week. One is the lecture slide, and over there you get you will learn about the router stuff. What do you have? How do you type the commands? What are the privilege level that you have on the router? So we'll go through them in detail. You don't have to worry about the slides. Now there's another file on to build your cheat sheet. So what that means is that because there are too many commands when it comes to configuring a router, and we only want to remember, we don't say remember, we want to keep the command that is very useful that we will be using quite often. So by the end of this class, we will build our own cheat sheet. If you are gamers, you know what is a cheat sheet, right? So all the cheat code that you will use so that to turn on the God mode, and then you cannot die. That is just cheat lah. So today, I want you to have that also, meaning that later on we will create a text file and then we paste all the code or all the command that you type. And the reason for that is because during the lab test, in your lab test 1, you will need all these commands. Now, of course, you can always refer back to your lab manual because this is online test. But it will take you a lot of time because there are too many things that you need to find and go through to get what you want. So later on, you will have your own cheat sheet. You keep it with you, stick it on the toilet. So every time you go to the toilet, you'll be staring at the command that is very important. And with that, when you do lab test 1, it will be very easy because you already know what do you want to type in the router. Okay. Now, if you're ready, I will start the video for you, and after that, we'll get to packet tracer. Hey guys, so this week we are going to learn how to configure network routers, which is part of what network administrators do day to day. So it is good to know that we do not always need a router. In this example, we'll be looking at when should we use a switch and when should we be using a router. So over here, we have 2 PC0 on the left and PC1 on the right. PC0 is currently having the IP 192.168.1.1, while PC1 is having the IP 192.168.1.2. Both of the address is having a /24 mask, so from here we can tell that they are actually in the same local area network. And that's because both of them are having the same network address of 192.168.1.0/24. So now we have the choice of connecting these 2 PC with either a switch or a router. we're going to start by connecting them with a switch first. So once the physical network is built, we can now do a connectivity test by using PC0 to ping PC1. If the ping request is successful, this means that switch is the right device to connect two PC that are in the same LAN. So yeah, there we get it. We can see that PC0 is able to ping PC1, which means that for us to connect devices within a same local area network, we only need to connect them to a switch. Now we are going to add PC1 into a separate LAN running on 192.168.2.0, and PC1 will be using the IP 192.168.2.2. As you can see on the diagram, PC1 is now located on a separate physical LAN from PC0, which is shown in green color. Now, we will do a ping test to check if PC1 is still be able to ping PC0 or the other way around when they are both located in two different networks connected by a switch. Uh-oh! So from the ping test, we can tell that PC0 can no longer ping PC1 in these current configurations. This means that a network switch does not connect two devices that are located in two different physical networks. So right now, we are going to replace this switch with a network router. For the rest of network configurations and IP setting, we will keep all the addressing the same. So really, the only changes we have made is on the type of network devices that we are using to connect both of these devices. Now, let's do a ping test from PC0 to PC1 to find out if PC0 is able to ping PC1 with these current configurations. Oh yeah, we got it. This means that when we replace a switch with a router, PC0 has successfully pinged PC1. In other words, we can tell that a router is the network device that connects two devices from two different physical networks together. This is a Cisco 1841 router. A router is just like any other computer devices, except that they are specially built to route and forward packets. Because of that, a network router has most of the components that you can find on a normal general purpose computer machine. Now let's zoom in and take a look at the architecture of a Cisco 1841 router. So here you can see that the router is actually powered by a CPU processor M860. This is a special purpose chip that Cisco designed to optimize the workflow to forward and route network packets. Now if you're asking, can we use any Intel processor to run on a Cisco router? Yes, it is possible, but we will have to rewrite the whole operating system that is running on the Cisco router to run on the Intel processor architecture. So you should also notice there is a SD-RAM up to 128 megabytes that is currently built in on this router, and this is again expandable to 348 megabytes. So depending on how complex your configuration is and how many routes that you want this router to support, you have the options to scale up or scale down the memory configurations on this router, just as if you would do on a common computer machine. Then you would also notice there is quite a number of slots that is built to support flash drive. And this is quite common in a Cisco router because network engineers normally carry around their network configurations on the router in a flash drive so that this is easily transferable to any other routers that they are going to configure in the futures during all the networking configuration pipeline. There's also a built-in flash up to 128 megabytes of size, but most of the time you will get 32 megabytes out of the box, and this is used to store the operating system of the router. So you might be thinking, wow, I can store an entire operating system in just a 32 megabytes of storage. Well, like we said earlier, Cisco router is running on the Cisco iOS that is heavily customized and optimized, which is one of the reasons the operating system do not take up a large storage footprint. So one interesting fact here is that this iOS is totally different from the Apple iOS that's running on your iPhone or your iPad or any Apple devices. So you can actually run Facebook or Instagram on a Cisco router. The NVRAM is a place where we store all the routing configurations that we have performed on a router, and it is always important for us to save the configurations from the random access memory RAM to the NVRAM so that the next time we start up a router, we can load up our previous configurations instead of starting anew. Then you will notice there are a few ports that are connected using the yellow colored line, which is all the physical interface that we have on this router. In this example, we have two fast Ethernet ports, which means that we can connect two network devices to this router to get to the internet, but most of the time we'll be connecting a switch to either these two ports, and we also have two slot 0 for some other network interface card. On the top left corner, you'll notice there is an aux and console port, which is where we connect the console and aux cable for us to configure this router. So coming up, we will be looking at how we can connect this router to a computer for us to perform some simple router configurations using the input-output device on the computer machine. So the first thing that you will notice when you're trying to configure a router is, hey, wait a minute, where's the display? And without a display, how can we know what we are configuring on the router? That is actually a design decision, a smart design decision by manufacturers, because they know that we do not need a display on a network device so often unless when we are configuring these devices. Which is why, for us to configure any network devices like a router and a switch, we need to connect them to a machine that's having a display. And one of the best devices that is readily available would be the PC or the laptop that you are using. Now the next thing that we would like to find out would be all the ports that is available on this router. And specifically, we want to find out what are the ports that we should connect the PC to for us to configure this router. Looking closely at the back of the router, we see that there are fast Ethernet port in the yellow label, the console port in the light blue label, and we have slot 0 where we have the serial card attached. To the right of the router, it is a power switch for us to turn it on and off, and also the power cable that connects the router to the power supply. So now, the question is, when we want to connect this router to a PC for configurations work, what kind of cable and which port should we connect the router to? This is the console cable. The console cable allows us to connect the router to any device with a display. With that, we can start to configure the router using the input-output devices and the display on a remote machine. With the console cable, we will connect this end of the cables to this console port on the router. That's it. Now on the other end of the console port, where you have the slightly bigger head, this goes to the PC that's currently having a display. And the other end of the cable goes here into the machines that we are going to configure the router from. So that is how you connect your router to the PC. Now, the problem with the console connection is that you have to be physically close to the router for us to do the configurations. The easier way would be we connect the router directly to another router of the internet service provider so that we can get onto the internet. With that, we can connect to this router remotely from anywhere around the world to configure this router. Okay guys, so welcome back. By now you have already seen a Cisco router, a real Cisco router, and then I think, hold on a minute. And that router that we have just seen is 1841, which is the cheapest Cisco router that you can buy. Of course, now you have more better router, advanced router, which is faster. You can support more number of ports. But anyway, in our lab, we will be using the 1841. It doesn't mean that we cannot buy the expensive one. It just means that we want to learn from the simplest one so that you don't get confused. And yeah, we will go straight into packet tracer, and we'll see how we can connect the computer to a router for us to do the configurations. So before I go forward, can I know in the chat, please let me know if you're okay. If you're okay, then I need everyone to open up your packet tracer, and then we will build our own network from scratch. So are you ready, guys? Let me know if you're ready. Okay, so for us to do this, you need two things. One is packet tracer, and then another one is this file. You should get this file from Weber, and we'll go through one by one. By the end of this, when we finish all this, we'll get a big set of command, and that command will be the cheat sheet that you will keep with you, bring it with you anywhere you go, put it under your pillow when you sleep, because that will be very important for you. Okay, so you start packet tracer, and this time you want to open a new one. So if you are still running on the board, the builder file, then you just click on a new packet tracer, click no, and then you get to this screen. Now what I want to tell you is, first thing, whatever that you see on the video earlier, you will get the same thing on packet tracer. So earlier you seen the video, you see how I connect the router using the console cable. Now we will do exactly the same here. Packet tracer is so real, I tell you that whatever that you get in that video, you have the same exact replica copy in the simulation software, except the handsome guy that you see on the video is not here. Other than that, everything is here. Okay, so I think I have a lab coming up. That's why there are a few students who are joining my Zoom, so that's okay. So now, first thing, if you look at the bottom left, you will see all the control panel for all the devices, including the network device and end devices. Now in this lab, yours might be a little bit different because you are running on the Windows version. So just go click around, and then I need you to find under network device, you click for a router with the model number 1841. Now you will see there are many different routers, different versions, different model. So this is just like if when you buy an iPhone, you have iPhone 11, iPhone 11 Pro, iPhone 11 Pro Max. So for the router is also the same. So what are their difference? Some they are they have bigger memory, some they have more slots that you can connect to, and then some they are just physically bigger, things like that. So just like you have many different phone versions or model, you have that for router. So for you to take this device, there are two ways you can do this. You can either drag and drop, or you can just click and then left click on the workspace, and then you will get the device. So I need all of you to get 1841. Please make sure you get the right model, 1841. Put it on the workspace, and that is our new router. Okay, so we are going to get a new router based on the instruction 1841, and then we want to name this as Router Pro Max to make people know that our router is expensive. Now, there are two types of name in Packet Tracer. One is the display name, another one is called the host name. Display name is what you see here. On the workspace, you will see router 0. This is the display name. Okay, if you do not have this one, please go to preference to open this. So if you go to preference, there are a few options for you to choose what you want to show or not. Okay, now I didn't turn on device model label. You can turn it off, but I want the device name label here to know what is this device. Okay, so this is turned on right now, which is why I can see router 0. And for us to change the display name, you can just simply double click on the label here, and then you just name it like Router Pro Max in one word, just like that. This is how you can easily change the display name, but you have to understand that this display name it doesn't affect the operation. It is just the name that we see. So to the router itself, the router doesn't know about this. Okay. So for those who have issues, I will just answer you after the class, because the other students are still trying to work on this. So that is how you get a router. Now again, you can just find any routers here, find on the right model, and then just drag and drop, you get the router. Okay, now what we really want to do today is to configure this router. And before this class, we have played Bob, and during Bob the Builder, we configure IP address of the router by going to the config, right? And then we click on the right interface, and then we can change IP address. Now, starting from this day onwards, we can no longer do that. That's because what we are doing earlier is actually cheating, because like you've seen in the video, before this, there is on a router there is no display. So how can I go into a router and then I click and type IP address? Do you see a mouse on the router? No. So all the thing that we have been doing earlier is actually cheating. So for us to really configure a router, we can only use the command but not this interface here. Which means that in the exam, in your lab test, all these things will be disabled, meaning that you cannot click. When you click, it will say you cannot click. Which is why you have to learn how to configure using the command today. So we go back to the instruction set and let's read at the first one. First thing, we want to configure this router. So remember, again, two ways. Either you use a console cable or the Ethernet connections. Now, out of the box means this is a new router. New router, you cannot use Ethernet connections because it is not set up yet. For you to use the Ethernet connections, you need to open the telnet service in the router. So of course, when you buy a new router, you just take it out from the box. No people have configured telnet for you. So there is only really one way to configure this router, which is using the console connections. And again, like we said earlier, to do so, you need to find a PC with a display. So over here, you go to End Devices, find a PC, and then put it on the workspace. And this PC here will be the one that I will use to configure this router later. Okay, if you don't like the name PC0, you can always change this to admin or something. Okay. Now, after this, we want to connect these two devices together using the console connections. And all the cables here are under the connections, which is the thunder sign. Now, one thing I want you to know is that in datacom or in networking, we pray to many gods, but one of the gods that we pray to is Zeus, the god of thunder. because later on you will see this God of Thunder will help us to choose all the different kind of connections, different type of cable that we do not know what is the cable that I should use. When you click on the auto connections, then Juice will decide that for us, okay? But that's later. For now, we cannot do so because you have to specifically choose the console connections. So over here, if you look at here, this is exactly the same blue cable you see in the video console. Click on this one, go to the side of Router Pro Max, click here. Now you have to choose on the port console, okay? Because there are a few ports like what you seen earlier on the back of the router. You want to connect this to that console. So click on console, and then you just move the mouse to the admin PC, click on it, and then you choose the other end, like what you see in the video, RS232. That is it. That is how you link a PC to the router for us to configure the router. So now the next thing, we want to add an Ethernet card. So you see again, a router when you buy it, it is built as the baseline model. So just like your PC, if you are building your own PC, gaming rig, you know that some people want 8 gig, some people want 32 gig, because you think if you have more gig, then you can win more games. I'm not sure whether that is true, but the point is you can customize the router depending on what you want to do with the router. And to do so, you can just click on the router, and then you go to the physical tab, and this is where you can configure the hardware on the router, meaning that you can add card or take away some card. So if you cannot see this properly, you can always zoom in, and then this will get a bigger, clearer view on the router, the back of the router. Now on the left hand side here, this is all the kind of cards, expansion cards that you can buy and put it on this router. Of course, you can try anything because Packet Tracer, this is free. You don't have to pay money when you buy a card, okay? And of course, you have to be careful of the slot as well, because not all the card fits to different slots, so you have to see whether it fits properly to the back of the router. So that's one thing. Now, in this case, I want to buy the fastest Ethernet card that is supported on this router. Now, for your case, it might be different. I'm not sure whether do you have this one. If you do not have, you go for 1ENET. So 1ENET is Ethernet. This is just an Ethernet port, so it's 10 meg only. It's not too fast. If you do not have this, then you can buy this one. Now again, sorry, before that, I forgot to tell you, over here, if you go to the left, you see this power button. So always remember, Packet Tracer, if you do not turn on power button, you cannot add the card one, okay? Because Cisco is worried about you. They don't want you to get electrocuted. So you have to turn off the power, which is a good idea, because you see now TNB beer is so expensive these days. So always turn off the router if you are not using it. Now, for you to add the card, you have to turn this off first, and then you choose any card of your choice. You just click here, you pull the card, okay? Pull the card, don't let go, and then you drop it here. That is how you add a card to a router, and it's free, okay? That's the most important thing. Now, of course, if you have this card here, this is for gigabit Ethernet. This is very fast. This one is like 1000 megabits per second. So if you have this one, then you can put this card here. Okay, that is how you add and remove card. So how do you take away a card? So let's say today I am rich. Okay, my girlfriend want to sponsor me a faster card, so I don't want this anymore. You just left click here, and then you pull this all the way down to this corner here, and then you let go, and then this card will be removed. Okay, so this is how you add and remove card in Packet Tracer. So again, so let's say if I want to add this card, I click on this one, just like you go to Lazada, you click buy, and then this is the card. It arrived in your mailbox. You click this card, you move it all the way here, let go. That is how you add and remove any cards of your choice on the router. Okay, of course, all this you cannot remove, it's already built in. So if you have done so, you need to turn it back on. So let's say I only want to have one card. See, the other will be empty. Now this side here, what you can do next is you want to add a cover. So if you see here, there is a cover here. So normally you don't want to leave it exposed lah. If you put this, then because the weather is so hot, then cockroach go inside. Later your cat, cat can fit into any shape, Later your cat run inside. So you don't want your cat to go missing in the router. You take a cover and then you close it. Then nothing else can go inside. Okay. So this is the cover, and normally it will come with the router lah. Okay. And that is how I configure the router to the requirement. If you have done so, that means we have already done all the physical setup. So that's it. Remember to turn it back on, always turn it back on, then we can start to configure the router. Okay, if you do not turn on, then later on you ask me why I cannot configure, so turn it on first. So you close this one and we go back to the screen here. Now next thing, remember, of course, if you click on this router, you will see there is a tab called CLI. This is the command line interface, which is exactly the same thing that you will get later when you connect using a PC. So I will show you here how you connect. Go to the PC here, click here. Now go to the desktop tab where you get all the programs on the PC, and for us to connect to a router, you want to use this thing called the terminal. Terminal is like the command line interface that interface with the router. You click here, you see a few values. Now don't change any of this. We'll keep everything at default because these are all layer 1 informations. We do not want to mess with layer 1 stuff, so we'll just click OK. And in a short while, you will see a screen like this, which means that if you see this, you can just press Ctrl+C on your keyboard. Okay, you press Ctrl+C and then you will get to the router prompt, and that is how you know you have already successfully connected your PC to the router prompt. And here you can start to configure the router. So in fact, if you click on the router here, you will realize that this thing you see is quite similar. This one here and this one here. In fact, they are both the same. Okay. If you do any changes here, it will be reflected there. But you have to know one thing is that this one is actually not real. Okay. Remember, this is a simulation tool. By right, you cannot go to a router directly to do anything because there is no display. So it is something that doesn't exist, just like your girlfriend that doesn't exist. So in the exam, you cannot go to the router directly to do any configurations if the question asks you to configure from the admin PC. So that's one thing that you should remember. Now anyway, for this case, since this is just a practical, playthrough, so that's fine. You can use this one if you like to. If you think you like dark mode, then you use here lah. If you think you don't want dark mode, you want light mode, then you use here. But remember, they are both the same thing. Okay. So over here, I will be just using the CLI on the router. And once you have done so, it means that we are now in the warm up. So next thing I want you to do is you open up a notepad file, okay? Because I want you to copy back all the command that we do today. So you just open a notepad. For my case, it is text edit lah. And then we will keep all the command that you type today. So the first one is all the command that you want to do for warm up check. Okay, so later on we'll paste the command here lah. So I'll be doing this with you, don't worry. First thing, let's look at what we have to do. So I'll hide the camera first, and then I will put what you want to do on the left, and the commands will be shown on the right. So by now, all of you should have something like this, the router with a forward arrow prompt, okay? That means you can start to configure a router. So next thing you will notice is that on the router, when you press, okay, now next, I think I should tell this to you first. On the router, we have different level of privileges. On a PC, if you compare this to a PC, it is slightly different now. For a PC, when you log in, the only security that you have is the password, okay? So if you're using Windows 10, then when you log in, they will ask you for the PIN or the password or face recognition. So one level of security. When you get in, you can do anything on the PC. You can run any program as administrator, okay? Now for router is different. We have many levels, and the level is shown on this slide here. So you can get this table on the lab manual. So what you are seeing here on the screen is the level on a router. So why we have so many levels? That's the first thing. It's because we have different people that will log into a router, and all these people, they have different job role. They do different things. For example, I have a manager, so maybe the manager can see more stuff compared to a normal staff. Or maybe you have a newcomer who just joined the network, joined the company. So on his first day, you don't trust him so much, so you don't want him to see too many informations. So on a router, you see we have all this level, and at different level, you can do different things. Now, for example, in the user mode, let's start with the user mode. If you are here in the user mode, you can only see informations. You cannot change anything. But if you go into the privilege mode, you can start to set something like you can change the clock or things like that. If you go further down into the configurations mode, this is where you can change the setting on a router. Okay, now you can go even further to interface mode. So interface mode, you can change the IP address of a router. So the point is you don't have to worry about what you can do at what level yet. You just need to know there are many levels when you come to router operating system, and at different level you can do different things and you can see different things. Okay, so next, the first thing you want to know is that when you first get into a router, you will be at this level. We call this the user mode, which is why you see the prompt here. Okay, now after this, if you want to do more things, you have to go to the next level. So for you to go to the next level from the user mode to the privilege mode, you will type the command en. Okay, now let's go back to packet tracer and try this out. So I'm in the en this prompt right now, which means I'm currently in the user mode. Okay, so I want to get into the privilege mode. I will just type en, and then now you see the sign will change, the prompt will change to a hashtag, which means now I'm already in level 2. So if you go back to the now if we go back to the slides here, for me to go further, then it means from the hashtag go to level 3, then I will type the keyword called config t, which stands for configure terminal. So to do so, I go back to packet tracer. Now you have to look closely at the prompt here. If I type a config t, it will bring me to the next level, and then now you see the prompt will change to the config, which means now you are in level 3, and this is where you can start to change some of the settings on the router. But you cannot change IP address yet. Okay, now if you want to change IP address, you have to go back to the command here. You use the command called int followed by the interface number. So this is just an example here. So you see what I have is I put int fa00, that will bring me to that specific interface. Now for our example, we will just simply type any interface first. Or no, maybe we will just use the right interface. So you go back to your router here, and then if it is not showing you the port number, remember to check this port label to see the number. Now you do not have any prompt yet because you are not connected to any PC yet. You are just connecting an admin PC. So this brings us to one important thing. This thing here is not a network. It is not a LAN. There is no IP address. This admin PC, it cannot go to the internet. So this network here is only used to configure the router, but this is not a network. It is different from LAN 1, LAN 2, LAN 3 that we have seen earlier. Okay, that's the important part. So anyway, let's go back to the prompt here. And then just for an example's sake, you can type int fa00. If you do this, then you will see the prompt now change to a config if, which stands for configure the interface. And this is where you can start to change the IP address on a router. Okay, so next thing, if you go back here, and then you will see that we started from the user mode, and then we go all the way to the interface mode. So right now we are already here. So what if I want to go back up? I want to get out from the configure interface back to level 3. Then you can just press the Control C on the keyboard. So just give me a minute here. So again, let's say if you want to get out from the prompt, you're in level 4 back to level 3, you press the Control C. Now for you to get all the way back up to the user level, you type the command exit. Okay, so this is another 2 things that you should know. So let's get back to the prompt here. See, now I'm in layer 4. Level 4, I want to get out, I press the Control C on my keyboard. Now I will go back to the privilege mode. Okay, I'm already in the privilege mode. If I want to get all the way out from the privilege mode, I type exit. Then I get back to the user mode. With, you know you are in user mode when you see the right arrow sign. So again, just very quickly, for you to go from level 1 to level 2, you type EN. Go from level 2 to level 3, you type config T or conf FT is also okay. Now from here to go to interface, you type the interface name. INT stand for interface FA00. You're already in level 4. Now for me to go back up, I press Ctrl C. To go all the way out, I type the command exit. That's it. Okay. So what we have covered so far is you already know how to get into a router to do some configurations, and on the next lecture we'll continue with the rest of the configurations, which is something that is similar to what you'll see in this lab. So I hope all of you will attend the lab and try to understand as much as you can, and after the next lecture you will get you will get a clearer picture on why you are doing what on the lab. Okay, so I will stop here. That's it for the lectures today, and as a summary, you have finished up network addressing, and we have already started on how to configure a router. Okay, so if you have any questions, drop it on the chat. If you are fine, then that's it. Thank you for joining. Until then, see you again. Okay, now for those the interface one, you might be having different interface, so it could be Ethernet E00 or FA. That's fine. You don't have to worry about what is the syntax first. As we go on further, you will get an example, and then you will know what is the right interface to put in. Okay. Yeah. So thanks for joining, guys. Bye bye. And remember, there is no class on Friday. Yay! But you have a quiz. Okay.